Alright guys, so sorry I couldn't be here today, but today we're going to do just a very short notes on lessons, and then we're going to look at factoring by grouping. So you'll notice that some of these were actually on your factoring greatest common factors, and so this is just going to kind of be a continuation off of factoring by greatest common factor. So what we're going to do here today is specifically called factor by grouping. Okay, and the reason why it's called that is, so factor by grouping we typically use if there are four terms, right, and in which none of those four terms have a common factor. Okay, so there's a little process that we're going to follow here, and it's really not that bad. So if we take a look at the first problem, I've got 3x squared plus 6x plus 4x plus 8. Okay, so when you think about the GCFs, right, the only number that can divide 3 is 1 and 3. Right, but 3 can't divide into 4 or 8. The 8 doesn't have an x. So between all four terms, there's no GCF. So what we're going to do instead is we are going to split them, okay, into two groups. All right, so I'm going to split my first group up into the 3x squared plus 6x. The second group into the 4x plus 8. Okay. Then we are going to factor the greatest common factor out of each group. Okay, so the GCF in the first group is 3x. The GCF in the second group is 4. Okay, so what we're going to do is now we are going to factor those out of each of the groups. So I'm going to put my GCF out. Remember, when we factor it out, we're going to divide each of the terms by the GCF. So 3x squared divided by 3x. The 3 divided by 3 is 1. Okay. X squared divided by x, we're going to take an x away, so I'm left with 1x. 6x divided by 3x, the 6 divided by 3 is 2. We take an x away from x, and there aren't any left over. So we're left with 1x plus 2. Okay, now we do the same thing with the second group. This time my GCF was just 4. Okay, so we're going to put a positive 4 right here. Okay, that's my GCF here. And then 4x divided by 4. The 4 divided by 4 is 1. The x, we're not dividing it by anything, so we bring down the x. 8 divided by 4 is 2. Okay, so that was our second step. We factor the greatest common factor out of each group. Now, third step. In order to factor by grouping, there has to be a common binomial expression. Okay, remember, a binomial is just a two-termed expression. So if you notice here, we have x plus 2 and x plus 2. That right there, that is going to be our new common factor. So what we're going to do is we're going to pull out the x plus 2, all right, to the outside, and then our second factor is going to be 3x plus 4. So we're going to bring these out as x plus 2, right, and then we have left over 3x plus 4. Okay, so one thing you can always do once you're done factoring is you can always check your answers. Now remember, we factor, so we take a big expression, we pull it into two smaller ones. So when I'm checking, I'm going to take my two smaller ones and put it back into the bigger one. So we're going to multiply them back out. Okay, now multiplying, there's multiple ways we can do it. We can use the box or the distribution method. I'm going to distribute here. So x times 3x is 3x squared. X times 4 is 4x. 2 times 3x is 6x. And 2 times 4 is 8. We combine our like terms. Plus 10x. Bring down the plus 8. Right? Well, and really this right here is what we started with, so we didn't really need to combine like terms. Okay, so this right here is our correct answer. Okay, so we're factor by grouping. Okay, so let's take a look at another one. Okay, so my first step, I look for a GCF. Okay, I actually have the same numbers over here, between 6, 3, 8, and 4. The only number that can divide all four of those is 1. Right? Not all of them have an n, so we don't have a GCF. Right? So my GCF of the first group is going to be 3n to the second. Okay, so remember, 3 is the greatest number that can divide 6 and 3. right? And when we look at the variables, remember, when we divide exponents, we subtract, so we're looking for the largest that can be taken away. Okay, so that's n to the second. So now we're going to divide. 6 divided by 3 is 2. N to the third divided by n to the second is n to the first. 3 divided by 3 is 1. We take 2 n's away from 2 n's. We don't have any n's left over. So inside we have 2n plus 1. Okay. The next group, my GCF, is 4. Right? So we're going to divide these by 4. 8 divided by 4 is 2n. 4 divided by 4 is 1. Right? So after we take out the GCFs, we should have a common binomial, which we do. So we're going to take this common binomial and write it out front. And we're going to write what we have left over in another set of parentheses. Okay. And this right here is your answer. Okay. All right, we got 2 more examples that we're going to look at together. Okay, and then you guys can work on some on your own. All right, for C, I've got 2n to the third plus n to the second minus 10n minus 5. Okay, so they don't all have an n. And this one doesn't even have a number, right? So the only thing that can be divided by that is 1. So we're going to split it up into 2 groups. Here, all right? This one doesn't have a number, so there can't be an integer for our GCF. But we can take out 2 n's. So that's what we're going to do. My GCF is 2. So when I take 2 n's away from this, we end up with 2n to the first. Take away 2 n's from this, and I'm left with 1. Okay. My GCF in the second group. Okay, remember I mentioned one point when we talk about greatest common factors, and your first number is a negative, we're always going to want to factor out a negative. Okay, so here my GCF is going to be a negative 5. So then when we divide negative 10n by negative 5, we end up with a positive 2n. We divide negative 5 by negative 5, I end up with a positive 1. Okay. And so once we take out those GCFs, notice what in the parentheses. We have 2n plus 1. So now we can say my answer is 2n plus 1 times n squared minus 5. Okay. All right, and the last one. All right, so for D, okay, we're going to group them. GCF of the first group, 21 and 12. Okay, the greatest number that can divide those is 3. And the most exponents we can take away is n to the second. Right? So here, we divide 21 by 3, I get 7. Take 2 n's away from n to the third, I end up with n to the first. Divide negative 12 by 3, and I get negative 4. Take 2 n's away from 2 n's, we don't have any left over. So it's 7n minus 4 for the first group. All right, the second group, I've got 7n minus 4. All right, now notice what you have here and what you have after you factored out the GCF of the first group. Right? Notice that they're already the same. Okay? So what I want you to notice next is between 7 and 4, there's no number that can divide both of those, nor do they both have a variable. Okay, so in this case, our GCF is 1. Now typically when we have a GCF of 1, we don't do anything with it. But when we factor by grouping, we have to write out the 1. All right, and I'll show you why. So then we put the 7n minus 4 in parentheses. Okay, so now we can see, notice that I took the GCF out of 1. We have those common groups. We have the 7n minus 4. So we can write the 7n minus 4, right? In my leftovers, the reason why we had to have the 1 there is because we needed a second expression to write in our second factor. Okay, so your factored form is 7n minus 4 and 3n squared plus 1. Okay, all right, so you guys are going to be working on a worksheet where you're going to be factoring by grouping. There's going to be a little puzzle for you to fill out, and that worksheet needs to be turned in at the end of class. You shouldn't have any homework for tonight other than if you have not finished those online lesson quizzes. Okay, so if you have not submitted those 3 lesson quizzes, you need to make sure that you're doing those. Okay, A lot of you guys have missings, and they're hurting your grade right now. Okay? I'll see you guys next time I see you.